Hi, I'm Ankit Panda of CAC department, fourth year. I'll be talking about my work in IIT Guwahati in the summer of 2019 as my internship. Uh, I worked I worked on splicing motifs inference in genomic sequences. There have been a lot of neural network models which have taken genetic sequences as input and have learned features on their own. But what seems to be lacking is procurement of inferable motifs through the genetic sequences. So we have worked on four visualization techniques which generate a visualization score based on which we can interpret the significance of every nucleotide in the genetic sequence. So I worked on a BLSTM neural architecture in which I implemented an attention layer. So we'll be talking about the code that I managed to write, which was first of all I had we chose the GRCH38 genetic sample from the genomic bank, and as you can see we have test positive, test negative, and train negative and train positive. So I'll just open up the test data to show you how it looks like. So as you can see, there are combinations of A, G, T and C that are the basic nucleotides which constitute the human genome. So we got about 164 samples, 164 base pair length, 2 lakh samples of sequences in our test positive and test negative, and similarly for the test negative and for the train positive and train negative. So let's have a look at the code. So first of all I take the test positive data, and then I split it, and using a dictionary mapping I assign integer values to A, G, T, C and N. N will be a replacement nucleotide which is used in visualization. So all of the entire input sequence that I had, that is AGTC, is now converted into a sequence of 1, 2, 3 and 4, as you can see here. So now I take that sequence into a NumPy array, which constitutes the positive data. Now I'll be talking about the test negative. I do the same thing for the test negative data, and then I reshape both of the test positive and the test negative data into a single NumPy array, and then append both of them. And I shuffle the entire data set so that there's a sort of randomness of positive data and the negative data in the training. Now I do a one hot encoding, in which every positive sequence is encoded with a 1 and every negative with a 0, and this entire NumPy sequence is then feeded up to a BLSTM network. And here we have the accuracy measures, that is recall, precision and F1. Now we got in our given architecture, we got about 100 neurons in the LSTM and 2048 connected layer plus a softmax layer. So as I train this, we got a 67. This is a test data set. So as you can see, we got a 67.9% accuracy in test, and while in train I managed to get about a 90% accuracy.